Your checkout button just froze because an email server on the other side of the world is having a bad day. The payment went through fine. The order was saved, but the app is still spinning, waiting on a service that has nothing to do with taking the customer's money. That is what happens when your services talk by waiting on each other. One slow piece and the whole request grinds to a halt. Over the next 10 minutes, I am going to show you the pattern that fixes this, the way modern systems talk without ever waiting. It is called a message queue, and once you see it, you will start spotting it running quietly underneath half the apps you use every single day. Here is what actually goes wrong when services talk directly. Say service A needs service B to do something. The obvious way is a direct call. A asks B, then A sits there and waits for B to answer. This is called being tightly coupled, and it has 3 nasty failure modes. First, if B is slow, A is slow, that wait passes straight through to your user who is now staring at a spinner. Second, if B is down, A's request fails even if A's own job was already finished. And third, this cascades. O is waiting on B, but something upstream is waiting on A, and one dead service at the bottom can freeze the entire chain above it. You have turned one small problem into a total outage. So good systems do one simple thing instead. Instead of calling B and waiting on the line, A writes a little message that describes what needs to happen and drops it into a queue. Then O is done. It moves on immediately. It does not care whether B is fast, slow, or completely asleep. Later, could be milliseconds, could be minutes, a service B picks that message up off the queue and handles it on its own schedule. A never talk to B directly. They never even have to be awake at the same moment. That is the whole idea. Replace a phone call where both sides are stuck waiting on the line with a message where the sender fires it off and gets on with its life. Picture the ticket rail in a busy kitchen. A waiter takes an order, clips the ticket onto the rail, and immediately walks away to serve the next table. The waiter does not stand at the pass watching the chef cook. The chef pulls tickets off the rail whenever a station frees up in order at their own pace. The rail is the queue. The waiter is the producer, dropping work off. The chef is the consumer, picking work up. If the kitchen gets slammed, tickets stack up on the rail, but nobody stops taking orders and no order gets lost. That little strip of paper is doing something profound. It lets 2 people who work at completely different speeds cooperate without ever blocking each other. Every one of these systems has the same 3 parts, and the names are worth locking in. The thing that creates a message and sends it is the producer. The thing that stores those messages until someone is ready is the queue, sometimes called the broker. And the thing that reads messages and acts on them is the consumer. Producer, queue, consumer. Messages flow one direction, in from the producers, held in the middle, out to the consumers. The beautiful part is that each side only ever knows about the queue. The producer does not know who consumes or how many consumers there are. The consumer does not know who produced. You can add 10 more workers or swap one out entirely and nobody else has to change a single line. Let us watch what decoupling actually buys you. Go back to that direct call. Service B goes down. In the old world, a calls B gets nothing and a fails 2, the failure spreads outward. Now add a queue in the middle. Service B goes down again. But it does not call B, A just drops its message on the queue and reports success. The message sits there, safe, waiting patiently. 10 minutes later, B comes back to life, sees a pile of messages waiting for it and works through them like nothing ever happened. The user never saw an error. Nothing was lost. That is the headline benefit. The queue absorbs failure. Your components can crash, restart, and deploy independently, and the work simply waits for them instead of falling on the floor. Now here is the part that saves you at 3 in the morning. Traffic is never smooth. You get spikes, a product goes viral, a sale drops, a big account posts your link. Suddenly you have 10 times the normal load slamming into your system all at once. If every request had to be handled instantly, your workers would drown and start failing. But with a queue, that incoming flood just piles up in the middle. Your consumers keep pulling at their steady, sustainable rate, and the queue quietly holds the backlog until the storm passes. This is called buffering or backpressure. The queue acts like a shock absorber between a bursty front end and a steady back end. You trade a little delay for not falling over. For most work, that is a trade you take every time. This same trick powers a ton of everyday work. Anything that does not need to finish before you answer the user. Think about signing up for a service. The instant you hit submit, your account is created and the page moves on. But the welcome email, that gets dropped on a queue and sent a second later by a totally separate worker. You did not wait for the mail server. Same with uploading a video. The site accepts your file immediately, then queues the heavy jobs, transcoding it into every resolution, generating thumbnails for a fleet of background workers to chew through. Notifications, receipts, image resizing, report generation, syncing data off to another system, all of it is work that belongs on a queue so your user never has to sit and wait for it. The rule of thumb is simple. If the user does not need the result to keep going, do not make them wait for it, hand it to a worker and answer them now. And the scale here is genuinely hard to picture. These systems are not toys for small side projects. They are the plumbing underneath the biggest companies on Earth. Kafka, the most popular streaming platform, was built inside LinkedIn and open-sourced back in 2011. A single properly tuned cluster can move millions of messages every single second. Think 2 million, 3 million, sustained all day long. Companies like Uber and Netflix push trillions of messages a day through this kind of infrastructure. Every ride request, every play button, every click event streaming through pipes exactly like the one we have been drawing. So when you hear that a queue can handle millions of messages a second, that is not marketing for these systems, that is just a normal Tuesday. Now for the split that trips people up, because there are really two flavors of this idea, and they behave very differently. The first is a true queue. A message goes in, one worker takes it out, handles it, and it is gone, consumed, deleted, done. It is like that kitchen rail, each ticket is cooked exactly once. This is perfect for distributing tasks across a pool of workers, where every job should be done one time and only one time. The second flavor is a log or a stream. Here messages are not deleted when they are read. They are appended to a durable, ordered log that sticks around, and any number of different consumers can read through it independently and even replay it from the very beginning. Same core idea, two very different tools. A queue is a to-do list you work down and throw away. A log is a history book you keep and can reread whenever you like. Getting this distinction right is most of the battle, because it decides everything about how your system is allowed to grow. On one side, you have the classic broker, the tool that treats each message as a task to hand out. You will see this pattern in brokers like the one on screen. A producer publishes a job, the broker routes it to a queue, and whichever worker grabs it first does the work and acknowledges it. The message then vanishes. If you have 100 thumbnails to generate and 10 workers standing by, the broker fans those jobs out so that each thumbnail is made exactly once, and the load spreads evenly across the pool. This is the workhorse for background jobs and task distribution, reliable delivery, flexible routing, and a message that is meant to be consumed a single time by a single worker. When your mental model is a to-do list that gets steadily worked down, this is the shape you want. On the other side sits the log, and this is where Kafka lives. Kafka does not think of a message as a task to delete, it thinks of it as an event to remember. Every event is appended to an ordered, durable log and kept around for days or forever, if that is what you want. That unlocks a completely different superpower. Many independent teams can read the exact same stream for completely different reasons. One consumer updates the live dashboard, another feeds the fraud model, a third quietly archives everything to cold storage, all reading the same events, each at their own pace without ever stepping on each other. And because the log is replayable, a brand new service can spin up next year and read all of history from the very start. Task distribution versus a permanent record of what happened, that is the real difference. So what is actually inside one of these messages? Nothing scary, usually just a small blob of text, most often a bit of JSON. It describes an event or a job, what happened, and the handful of facts a worker needs to act on it. Keep it small and self-contained. A good message carries an ID, a type like order created, maybe a timestamp, and the key data, an order number, a user, and amount. That is it. The producer does not attach code or instructions. It just states a plain fact and lets each consumer decide what to do with it. Small, clear messages are what let this whole thing stay loosely coupled. The producer and consumer only have to agree on the shape of this one little envelope and nothing else about each other. There is one promise you have to plan around, and it catches almost everyone. Most of these systems guarantee at least once delivery. That means a message is delivered one or more times. Occasionally, the very same message shows up twice because a worker processed it but crashed before it could confirm, so the queue hands it out again just to be safe. If that message says charge the customer $20, running it twice is a very real problem. The fix is a word worth memorizing. Make your consumers idempotent. Idempotent just means that handling the same message twice has the exact same effect as handling it once. You do that by giving each message a unique ID and remembering the ones you have already processed, so a duplicate is simply ignored. Design for duplicates from day one, assume every message might arrive twice, and this entire class of bug just disappears before it can ever bite you in production. A few honest warnings before you ship this. First, ordering. Within a single lane you usually get messages in order, but the moment you spread work across many workers, strict global ordering goes out the window, so do not assume it. Second, poison messages. Sometimes a message can never be processed, bad data, a bug in the worker, and it will retry forever, jamming the whole line behind it. The fix is a dead letter queue. After a few failed tries, shunt that message aside for a human to look at later and keep the line moving. And third, the big one, do not reach for a queue when you actually need an answer right now. Queues are for fire and forget work. If your user is standing there waiting on the result of this exact call, a plain direct request is still the right tool. Async is a feature, not a religion. Let us pull the whole idea together in 3 lines. 1. Instead of calling another service and waiting, you drop a message on a queue and move on at producer, queue, consumer. 2. That decoupling is what buys you resilience and scale. Services fail independently, spikes get buffered, and slow work happens in the background without ever blocking your user. 3. Pick your flavor, a plain queue when each job should be done once, a durable log when many consumers need to read the same events over and over. Get those 3 ideas, and you understand the backbone of almost every large system running today. If message queues finally make sense now, do me a favor and subscribe. It genuinely helps the channel, and there is a lot more where this came from. This pattern does not live alone. Those millions of messages have to be handled by fleets of services that scale up and down on demand. So next in the series, we are going deep on the thing that orchestrates all those workers, how systems run and scale in production. I will see you in that one.